Chemist, and today we're going to look at balancing chemical equations algebraically. This is a great method to use when balancing by inspection is too difficult because there are so many species represented in a reaction, or that the balancing coefficients are going to be so big, balancing by inspection would take a long time. So the first thing we're going to do here is we're going to put a letter in place of each balancing coefficient, and we're going to solve for them. So what this does is we would say that A number of C10H22 plus B O2 is going to form C of CO2 plus D of H2O. Now that we've done this, we can go ahead and make an algebraic expression for each element. So if we were going to make one for carbon, we would say that 10A, because A times 10 is going to be the number of carbons on the left side, is equal to C, because we only have one carbon in CO2 over here, and it's the only carbon on the right side of the equation. Now we're going to make an expression for hydrogen. 22 times A is going to be equal to 2D. And now we're going to do oxygen last, which I would strongly recommend because oxygen is going to appear in the most places. Therefore, in order to solve for B, the number of oxygens we're going to need, we're going to need to know A, C, and D first. So if we were to write an expression for oxygen, it would be 2B is equal to 2C plus D. Now that we've done this, we can just go ahead and set A equal to 1. Now, if A is equal to 1, it's because C is equal to 10 times A, therefore C is equal to 10. Now we can look at the hydrogen expression. So if A is equal to 1, 2D is equal to 22 times A. So 22 times A, which is 1, is 22, is equal to 2D. So 22 divided by 2 would make D equal to 11. Now that we have A, C, and D, we can solve for B. So 2B is equal to 2 times 10, because that is C, plus 11. Simplify that, 2B is equal to 31. Simplify it again, B is equal to 31 halves. Now I would keep it in fraction form. It's going to make it easier to simplify in a moment. So now we found that A equals 1, C equals 10, D equals 11, and B equals 31 halves. So we have those solved. So now we can write our balanced chemical equation. So we know that 1C10H22 plus 31 halves of O2 is going to form 10 CO2 plus 11 H2O. Now this is a balanced chemical equation, but it's not in its simplest form because we have a fraction here. So because 2 is in the denominator, if we multiply everything by 2, we will be able to get rid of that denominator. So we're going to multiply the entire chemical equation by 2, which is going to give us 2C10H22 plus 31 O2 is going to give us 20 CO2 plus 22 H2O. Now this is a balanced chemical equation. Now we can check it by inspection. So we have our reactants and our products, and we have carbon, oxygen, and hydrogen. So on our reactant side of the equation, we have 20 carbons because we have 10 times 2. So that's 20. On our product side of the equation, we have carbon appears once on that side, and we have 20 CO2s, so we have 20 carbons. Now for oxygens, we have 31 times 2, which is 62. And then on the products side of the equation, we have CO2, so there's 2 oxygen times 20, that's 40, plus 22 times 1 is 62. And then hydrogen, we got 2 times 22 on the reactant side, which is going to be 44. And on the product side, we have 2 times 22 again, that's 44. So as we can see, we have balanced our chemical equation, and this is as simplified as it can be. So that is how you use the algebraic method to balance difficult chemical equations.